Welcome to Thought Frontier.
Welcome to the deep dive. Today we're diving into a question that's been around since, well, the beginning of time itself. Why does the universe exist?
It's a question that's incredibly simple and unbelievably complex at the same time.
I know, right? It's one of those things that's so fundamental you almost never stop to actually think about it.
Yeah, like it just is.
Exactly.
Yeah.
So, to really tackle this question, this cosmic conundrum, we've got three really interesting sources to help us out.
Oh, cool. What are we looking at today?
First, we've got this recent article I found called Our Universe Isn't Supposed to Exist.
That's ominous.
Yeah, it gets right to the point. It's all about cutting-edge antimatter research.
Oh.
Then we'll switch gears a bit and look at a philosophical essay just called Why Does the Universe Exist?
Yay!
And finally, we'll dive into Stephen Wolfram's ideas about the universe as a computational system, which is mind-bending, to say the least.
I'm really excited to dig into that one.
Yeah, me too. It's really interesting to see like a scientific, a philosophical, and a computational lens all focused on the same question, almost like a three-dimensional view of this ultimate question.
Yeah, multifaceted.
Exactly. So let's start with the science. The antimatter article basically drops this bombshell right up front. The universe as we know it shouldn't even be here. It should have vanished billions of years ago.
So, like, poof, gone.
Yeah, basically. It all comes down to this mystery of antimatter.
Okay, well, first I gotta ask, what even is antimatter? I feel like I've heard of it, but I couldn't really explain it.
Yeah, it's one of those things that's kind of hard to wrap your head around.
Right.
So basically, it's matter's mirror image,
Yeah.
same mass, but with opposite charges. So like a proton has a positive charge, right? Well, antiproton has a negative charge.
Okay, I think I'm following.
And here's the catch. When matter and antimatter meet, they annihilate each other, releasing a burst of pure energy. Poof.
Oh, wow. I'm starting to see the problem here.
Yeah. Picture this. The Big Bang happens. It creates equal amounts of matter and antimatter. And what happens?
Well, if they have opposite charges and the same mass, then I guess
They
collide.
Exactly. They collide and boom, gone. All that's left is energy, no galaxies, no planets.
And definitely no podcast listeners.
Exactly. But obviously something went wrong with this whole annihilation plan because, well, here we are. And the article points to some recent research that makes this whole puzzle even more interesting.
Ooh, tell me more.
Well, scientists have been trying to figure out if antimatter reacts to gravity the same way matter does.
You mean, like, does antimatter fall up?
Right. That would have been wild, wouldn't it?
That would change everything.
I know. But sadly, no.
Oh.
This new research shows that antimatter responds to gravity just like regular matter.
Huh. So that rules out one explanation.
Okay, so back to square one. We know the universe exists. We know antimatter should have wiped it all out. And now we know gravity isn't the answer. So where does that leave us?
Yeah, that's a good question. It's easy to think of this as just like some abstract physics problem. But this matter-antimatter asymmetry really does have huge implications for why we're even here.
Yeah, it's not just about the tiniest particles. It's about the entire universe and our place in it.
And it might even hold the key to things like new sources of energy or crazy space travel technologies.
Ooh, very cool. So this tiny particle mystery could be the key to understanding the vastness of the universe.
Yeah.
And maybe even our future among the stars. But since we're already in this existential headspace, why don't we wade into the philosophical side of things?
Yeah, let's do it.
Our essay today asks some pretty heady questions. Why is the universe the way it is? Why does it seem so perfectly set up for life to exist? Is it all just a coincidence, or is there some deeper purpose? What do you think?
Well, philosophers have been asking these questions forever. It's a puzzle with like a zillion pieces.
And you might not ever solve it.
Right. But
But-
that's kind of what makes it so fascinating.
Exactly. It's the ultimate mystery.
So what does the essay say? Any good theories?
Well, it starts with that classic theistic argument. The idea that a divine being created the universe with a specific plan, and that plan includes us.
Okay, so like God created the universe.
Yeah, basically.
But even if that's true, it just kind of shifts the question back a step, doesn't it?
Yeah. Instead of asking why the universe exists, we're asking why this creator made it in the first place.
Right. Like, what was their motivation?
Exactly. And it brings up that age-old problem of evil. If this creator is all-powerful and all good, then why is there so much suffering in the world?
Yeah, it's a really tricky question.
Definitely makes you think. So if a divine creator isn't the answer, what are some other options?
Ooh, yeah. What else is on the philosophical menu?
Well, there's a many worlds hypothesis.
Oh, I think I've heard of that.
This one's a bit wild. It suggests that all possible universes actually exist.
So you mean like there's a universe where dinosaurs never went extinct?
Exactly. Another one where gravity works in reverse, maybe even one where pineapple on pizza is like a delicacy.
Okay, I'm listening.
The idea is that if every possible combination of physical laws and conditions exists well, then it's not really surprising that at least one universe would end up with life as we know it.
It's just probability, right? Like if you roll the dice enough times, eventually you're going to get snake eyes.
Exactly. It takes the pressure off in a way.
Yeah.
No need for a grand purpose.
We just happen to win the cosmic lottery.
I like those odds.
But the essay also mentions this more abstract concept, the idea that things exist because they ought to.
Okay, this one sounds a little out there.
I know, right?
What does that even mean?
It's this idea that existence itself is inherently good or desirable. So things exist because that's just the way it should be. It's saying that existence doesn't need a cause, it's just intrinsically valuable.
So like the universe has an inherent right to exist.
Exactly. It's more of a philosophical way of looking at it.
Yeah, it's definitely different.
So we've got a divine creator, an infinite multiverse, and a universe that simply exists because it ought to. It's a lot to think about. Which of these resonates with you? Ooh, that's a tough one. I think I'm leaning towards the many worlds hypothesis.
Yeah.
It's a bit mind-boggling, but I just find it so intriguing. What about you?
Honestly, they're all pretty mind-bending. What I find so fascinating is that these philosophical arguments force us to confront just how little we actually know.
Yeah.
It's like we're standing at the edge of a map looking out at a vast, unexplored territory.
A whole world of the unknown.
Exactly. But I have a feeling Stephen Wolfram might have a map for us after all. Ready to dive into the computational universe.
Absolutely. Let's do it. Okay, so Stephen Wolfram, he definitely takes us on a wild ride. His view of the universe is so different from everything we've talked about so far.
Yeah, he's not afraid to think outside the box, that's for sure. So he basically suggests that the universe isn't just described by math, but that it actually is math.
Whoa.
I know. Or more precisely, he says it's computation. It's like reality is just one giant computer program.
Okay, so instead of thinking about particles and forces, we should be thinking about algorithms and data.
Yeah, that's a great way to put it. He calls it a paradigm shift for a reason.
It makes you wonder if the universe is like one giant computer running a program that's been going on for billions of years.
Right. And all this complexity we see around us, it could all come from a set of surprisingly simple rules.
Okay, wait, so is this where that principle of computational equivalence thing comes in?
You got it.
Okay, so remind me what that is again.
So it's this idea that even really simple rules, when you apply them over and over again, can lead to incredibly complex behavior. Think about those fractal images, the Mandelbrot set.
Oh, yeah, those are so cool.
I know, right? And they're generated from a really simple mathematical equation. Wolfram's argument is that the same thing is happening in the universe.
Okay, I think I'm starting to see where he's going with this.
So basically, all this mind-boggling stuff we see around us, from galaxies to life on Earth, it could all come from a set of surprisingly straightforward rules.
Huh. It's almost elegant in a way.
Right.
Okay, but then he takes it a step further, right? With that whole rule universe idea.
Oh, yeah, he does. Get ready, because this is where things get really mind-bending.
Okay, I'm strapped in.
So imagine a universe where all possible rules are running at the same time. It's like every possible computational path is being explored simultaneously.
Whoa, that's a lot of universes.
Right. Like an infinite number of universes all branching out.
So you're saying our universe is just one tiny branch on this giant tree of possibilities.
Exactly. And within this rule universe, Wolfram argues it's statistically inevitable that some sections will end up following the laws of physics as we know them. He calls it the inevitability of our universe.
So our universe isn't actually special. It's just one of many that happen to have the conditions for stars, planets, and podcasters.
You got it. Kind of humbling, isn't it?
Yeah, in a way.
It's like we're not the center of everything. We just happen to be in a region of this rule universe where the rules played out in a way that led to life.
Okay, but if all these other rules are running somewhere out there, does that mean there are universes where gravity works in reverse or time flows backward?
Those are great questions.
And could we ever, visit these other weirder parts of the rule universe?
Wolfram doesn't rule it out. But he says that accessing them would be incredibly difficult, maybe even impossible.
Oh, man.
I know. It's because our perception of the universe is shaped by what he calls our rule position. It's basically the specific set of rules that we happen to experience within this vast structure.
So it's like we're these tiny ants crawling on a giant tapestry, and we can only see the threads right in front of us, but we know the rest of the tapestry is out there, even if we can't experience it directly.
That's a perfect analogy.
Yeah.
Our rulio position defines what we experience as reality.
So even though these other crazy universes might exist, we're kind of stuck with the rules that govern our little corner of the Ral Universe.
Yeah, pretty much.
And that's a bit disappointing.
I know, right? But hey, at least we got podcasts.
True. So at the end of the day, what Wolfram is really suggesting is that the universe exists because it has to exist. It's like a logical necessity.
Right. It's a consequence of the existence of all possible rule sets.
Yeah.
But our experience of it, our reality, is subjective.
It's defined by that limited rulal position of ours.
It's both humbling and kind of exhilarating when you think about it.
I know. It makes you wonder if other intelligent beings out there experience reality the same way we do.
Right. Or maybe their rulio position gives them a totally different picture of the universe.
No, that is a really cool thought.
I know, right? It makes you wonder what else is out there beyond our understanding. So we've gone from antimatter to the rulio universe. That's a lot to process.
It really is.
But there's this one question that I keep coming back to. What does all this mean for us? You know, like if the universe is just this giant computer program playing out every possibility, does that take away our free will or purpose?
That's a big one. I mean, it really gets to the core of what it means to be human. And I don't think there's one right answer. Everyone's going to have to wrestle with that in their own way.
Yeah, true.
But one thing that I find interesting is that Wolfram doesn't see this computational universe as like cold or deterministic. He actually emphasizes that even though the underlying rules might be simple, the stuff they create is incredibly diverse.
It's like music, right?
Yeah, exactly.
You've got individual notes, but you can arrange them in infinite ways to create all these different emotions and experiences.
Right. So the simple rules, the algorithms, they're like the musical notes, and all this complexity, the fact that we're even here having this conversation, that's the symphony.
Wow, I like that.
Yeah.
So instead of feeling small in this giant computational system, we should be amazed by just how much complexity and beauty can come from such simple beginnings.
Exactly. It really is mind-blowing when you think about it.
It is. And it makes you think about the importance of our own choices and actions, too.
Oh, yeah, definitely.
Yeah. Like, even if the universe is deterministic on some level, our experiences, our connections, the impact we have on the world, it all still matters.
I agree. Because ultimately, we're still the ones experiencing it, you know?
Yeah. It's like we're all actors in a giant play. The script might be written, but we still get to bring our own interpretations and emotions to the stage.
And those choices, those interpretations contribute to the overall story.
Exactly. So maybe our choices and actions, even the little ones, maybe they ripple out through this vast network and contribute to the universe in ways we can't even imagine.
Now, that's a cool thought.
Right.
Makes you feel like you're part of something much bigger.
It really does. Well, this has been an incredible deep dive. We've learned so much about antimatter philosophy and the computational universe. But even after all this, I'm still left with this one question.
What's that?
If our perception shapes the universe, like Wolfram suggests, could there be other ways of perceiving reality? Other universes that are so different from ours that we can't even begin to understand them?
It's definitely possible. I mean, that's the thing about these big questions. They push us to the very edge of what we can even imagine.
It's like climbing to the top of a mountain and realizing that there are whole mountain ranges stretching out beyond the horizon.
Exactly. But I think that's part of what makes it so exciting. The universe is full of mysteries, and it's up to us to keep exploring and keep asking those big questions.
Couldn't have said it better myself. So on that note, we'll have to leave you to ponder those mysteries for yourselves. We hope you've enjoyed this deep dive and that it sparked some new ideas or maybe even a sense of wonder at this crazy thing we call existence. Keep asking those big questions, and we'll see you next time for another adventure into the unknown.